Okay, welcome to Chapter 8, Lesson 6, Changes in Dimensions. Our learning target or objective for this lesson is to solve problems involving similar solids. Our vocab word for this is similar solids. They have the same shape and their corresponding linear measures are proportional. Okay, you may pause the video to write down the definition, then continue once you have. And moving on, we have our key concept for surface area of similar solids. Solid X is similar to solid Y by a scale factor, then the surface area of X is equal to the surface area of Y times the square of the scale factor. Take a peek at these cubes right here. Cubes to the right are similar. They have the ratio or the corresponding edge lengths is 8 to 4 or 2. The scale factor is 2. How are the surface areas related? Okay, if we take a look at the surface area of the smaller one, surface area equals, that has 6 sides, the cube, and each side is 4 by 4. Okay, we multiply that out. 6 times 16 gets you a long pause, gets you 96. Surface area is 96 of the small one. So reading into what our key concept is, we take the scale factor squared. So if we take 96 times 2 squared, we should get the same answer if we did the same thing with the larger cube as we did the smaller cube. So we have small surface area equals 6 sides. Each side is 8 by 8. Multiple 6 times 64. 6 times 64 gets you 384. That's the surface area for the large one. Now let's go back to our key concept, see if that matches up. We have 96 times 2 squared equals 384. So there you have it. So can you find the surface area of any similar figure? Just take the surface area of the one times the scale factor squared, and that will give you the surface area of the other figure. Let's move on to an example. Surface area of a rectangular prism is 78 square centimeters. What is the surface area of a similar prism that is 3 times as large? Okay, so we'll take our surface area of our smaller one, 78, times it by the scale factor of 3, square that. So we're going to have 78. 3 squared is 9. That is 3 times 3. So you have 78 times 9 gets you 702 centimeters. Centimeters squared. Okay, let's move on to our next example or key concept. We're looking at the volume now of similar solids. The volume, if the solid X is similar to solid Y by a scale factor, then the volume of X is equal to the volume of Y times the cube of the scale factor. So once again, instead of taking the square of the scale factor, we're taking the cube or to the third power. So let's take a peek at an example so we can put that into play here. A triangular prism has a volume of 432 cubic yards. If the prism is reduced to 1/3 its original size, what is the volume of the new prism? So instead of getting bigger on our new size, we're getting smaller. So we're going to take the volume. We're going to take the volume of our original 432 times the scale factor. Scale factor reduced 1/3, so that's going to be 1/3. And then we're going to cube 1/3. So we're going to take 432 times, this is 1/3 times 1/3 times 1/3, or 1/27. I'm sorry, 27. Not 1/27, 1/27. Okay, multiply 432 times 1, ABC 27, and you're going to get 16 yards cubed. Okay, let's take a peek at our next example, it's a real-world example. The measurements for standard hockey puck are shown at the right. The giant hockey puck at the left is 40 times the size of the standard puck. Find the volume and surface area of the giant puck. Use 3.14 for pi. So first what we need to do is find the volume and surface area of standard hockey puck first. So what we're going to do here is we're going to take our volume formula, which is pi r squared h. So multiply that out. Pi is 3.14 times our radius of 1.5 squared times our height of 1 equals, multiply that out, we get 7.065 inches cubed. And there's a volume of our standard hockey puck. Now we're going to look at our surface area. Surface area of there, we have 2 pi r squared plus 2 pi r h. Now we're just going to plug in what we have. 2 times 3.14 times our radius, 1.5 squared, plus 2 times 3.14 times our radius of 1.5 times 1. 2 times 3.14 times 1.5 squared plus 2 times 3.14 times 1.5 times 1 is going to get us 23.55 inches squared. Okay, that takes care of our original puck, but now we're looking for the volume and surface area of the giant puck in the wall. So once again, what we're going to do is going to find the volume of the giant puck. We're going to take the volume of this original times the scale factor of 40 and cube it. So now we are just going to plug in. Substitute. Volume is 7.065 times 40 cubed. Multiply that out, and the volume of the giant puck is going to be 452,160 inches cubed. Okay, now let's take a look at our surface area for the giant puck. Once again, you're going to take the surface area of the original, multiply by the scale factor, and we're going to square that. So our original surface area was 23.55 times 40 squared. So multiply that out, we're going to end up with 37,680 inches squared. Okay, there you have it. Find changes in dimensions for volume and surface area. So any questions, you may review the video, write down any notes, bring them to class, and this ends our chapter 8, lesson 6.